Hello and welcome to a new video. We've got lesson 13 for pre-calculus using the Math UC curriculum. I decided to really try hard with this this intro slide. Hope you like it. It's intimidating, right? To see all that math. Like, I'm intimidated and I know a lot of math, but I think it looks cool. So we're going to talk about the law of signs today, and hopefully it makes for a nice change from what we've been doing with identities, because it's going to feel a lot more like we're actually doing math. You will need a calculator, preferably one that is not on your phone. If you have to use your phone, downloading the Desmos app would probably be the best thing to do. Your regular phone calculator is going to make this tricky. But if you have a TI-84 or similar calculator, that's going to make it even easier. Before we get started on the law of signs, which is the new thing today, we need to remember some things from geometry that are going to help us out with both this week and next week. Just kind of some little things. Like, you could probably get away with not remembering them, or at least not remembering them very well, but they will help us out a little bit. So when we were in geometry, one of the big things that we do in high school geometry these days is we talk about how to prove that two triangles are congruent. So we make a big deal about it in geometry, I think partially because of how nice the proofs tend to be. They help our proof skills. And then also just because it's kind of neat to see the progression that happens, because essentially you start off by saying we know two triangles or two figures are congruent if all of their corresponding angles and corresponding sides are congruent. But that's a lot of information. For a triangle, that means knowing all three angles and all three sides. But if we logic through, right, and this is what we did hopefully in geometry, is we actually can eliminate things that we don't necessarily need. Like, we don't have to know all three angles are the same, because as long as two are the same, that third angle has to add up to 180 with the other two. So automatically we know that just from two angles and all three sides, we would know they're both the same triangle. And then we just kind of take it farther and farther to say, okay, what's the least amount of information we would need to know in order to be able to prove these triangles are congruent? And there end up being five congruence theorems that are listed here on this slide: ASA, AAS, SSS, SAS, and HL, which definitely feels like, you guys, what happened to your naming? So the A's and the S's are representative of the word angle and side. So ASA means that you have angle, side, angle. And the way we look at this when we're actually talking about the triangles is we're saying that if I know, like, that this triangle, if this angle is 35, and I know this side is 8, and I know that this angle is 83, and then on this other triangle, if I know that same information, then by the angle side angle theorem, congruence theorem, or whatever it is, I know that these triangles are congruent, that the rest of the sides and angles that I haven't listed also have to be the same as each other. So that would be angle side angle, because angle side angle means you know the side between two of the angles. Angle angle side would be that instead of knowing this side that's between them, I know one of the sides either direction. So maybe I know that this side is 10 and this side is 10. And so what we do is we look at this, if we say we have angle angle side. It's kind of weird to get used to at first, but hopefully that is ringing a bell from geometry. Hopefully you got the hang of that in geometry, and now it's just a matter of remembering it. Side, side, side is a nice one because it just means you know all three sides of each triangle, so you end up seeing that they're the same triangle. Side, angle, side means you know a side, the angle, and a side, so the angle has to be between the two sides. And HL is hypotenuse leg. It's a specific thing for right triangles. Now, what we can't use to prove triangle congruence is angle, angle, angle. If we know all three angles, that's great, but you actually could have a triangle that has all three angles the same, or two triangles that have all their angles match up, but one be little and one be big. Having angle, angle, angle only implies similarity, not congruence. And then there's another one that is conveniently not on the list, because if we accidentally spelled it the other way around, it actually is a word that we don't normally say in polite company. So this is not something that proves triangle congruence, side-side angle, but we're actually going to see it play a part a little bit in what we do today. So the whole reason for going through this, and maybe this took longer than it definitely took longer than I intended it to. We'll see how that works out after editing it. So the reason I bring all this up for us to remember is that we are going to learn in this lesson law of sines and in next lesson law of cosines, and it is going to help us know which one of those to use if we remember these kind of labeling systems. So that's kind of our, hey, remember from geometry. Now let's take a look at the new thing we're doing. So we've been working with right triangles exclusively so far as with like trig functions go. We use SOHCAHTOA and the Pythagorean theorem in order to find missing parts when we needed them. But that's not all the triangles in the world, right? Not every triangle is a right triangle. Some of them are a wrong triangle. It's funny because it's a pun, in case you didn't catch that. So that's not actually what we name non-right triangles. We don't name them wrong triangles. They have their own special name. They are called oblique triangles. So any triangle that's not a right triangle is called an oblique triangle. We do also have other names that we can name them, like, right? Like, my shirt actually says name the triangles and has Jeffrey and Frederick and Eugene. That's also not the kind of naming we're talking about. But like, if you're thinking of scalene and isosceles, equilateral, those are still names that we can use to classify triangles. But oblique is like basically we can divide all triangles up into either being right triangles or oblique triangles. Oblique triangles can also be other things. Now, the other thing that we need to address to make sure that this lesson makes sense is there's a really cool way we can name triangles that's helpful for us keeping track of the angles and sides that are across from each other. And the reason we would do that anyway is because there's a cool thing where the smallest angle is always across from the smallest side, and the biggest angle is always across from the biggest side, and then the middle is always across from the middle. And so what we do is we name them strategically to kind of address that relationship, that we use capital letters for the angles, and then we use lowercase letters for the sides, but we match them up so that angle A, which is right here, is a capital A, but then the side across from it that goes with that is a lowercase a. And that's going to be helpful. That's the naming convention that we're going to use in this lesson as we go along. The law of sines is something we can use to find the missing parts of a triangle. If they give us 3 pieces of information, then we can find the other 3 missing pieces. Now, they have to give us a certain kind of information in order for this to work, because essentially what's happening here is we're given 3 fractions, and it doesn't matter which of these 2 ways of writing it you use. It could be just a personal preference that you think one way looks easier than the other, but they literally are the exact same. I tend to use the first one, but I'll try to switch between them so that you can see it both ways. Anyway, what we'll end up doing is we'll actually end up just taking like 2 of these fractions and creating an equation that we can solve to get one of our pieces, and then we'll continue on until we have found all 3 pieces. So there are 3 situations that we can use law of sines for. We can use law of sines for angle, angle, side. We can use it for angle, side, angle. And we actually can use it for side, side, angle, which, if you remember, does not prove triangle congruence. So there's actually a special thing that happens with side, side, angle that the Math UC curriculum doesn't really get into, but I don't feel good about just completely leaving out. And so it's called the ambiguous case. And I might have a video that I can link to this so that you, if you're really curious about it, you can see what happens with the ambiguous case. But what's happening with side, side, angle is that we know 2 of the sides, and we know either the angle over here or the angle over here, okay? And so it ends up that there are certain situations where there is no triangle that works for that, right? Like we could end up knowing this side and this side, but then have an angle that's just too big and it doesn't create a triangle. So side, side, angle can actually give us a situation where there is no triangle. It can give us a situation where we have a triangle, one triangle, which would be really similar to what happens whenever we're doing angle, angle, side, or angle, side, angle. So the third situation we can actually have with side, side, angle is we actually have two triangles. And I'm going to show you a picture using Desmos of what that looks like what situation can make that happen. So let's see if this makes sense because of that. So here I have a triangle that I actually have, like, depending on how you look at it, 2 or 3 triangles, right? So imagine that we just have the blue triangle, blue inside. We know that we have an angle 39 degrees. We know that we have side 3.2, and then the side that's like coming through the middle of our big triangle, that side is 2.41. But that's not the only triangle that we can make with those 3 things happening, because I made another triangle that also has 2.41. So you can have the 2.41 going, hang on, you have the 2.41 going this way, or you can have it actually going over here, because we don't know anything about that angle up there. Not every single situation is going to be like that, but there are some situations where the information they give us could actually be representative of 2 triangles. So if we were to get into all that, one of the things we would do is we would work through a kind of a checklist kind of to figure out, does a triangle exist? If so, is it 1 or 2? And then we actually can find all of the pieces of both triangles. It's really cool, but also it's a really annoying thing to have to do. Math UC doesn't get into it, so we're not going to get into it. But like I said, if I have a video on it, then I will put a link in the description if you want to check it out. In the meantime, though, this is law of sines. It's pretty straightforward. Let's try some problems. Example 1. Find the unknown sides and angles. Doesn't say anything about rounding. We are going to be using our calculator, and it is going to give us things with lots of decimals. So the best practice would be to round to either 2 or 3 decimal places, not just the nearest whole number generally, and also to delay rounding as much as possible, because you can create a rounding error. And so nobody likes a rounding error, right? You could draw a picture of this if you found that helpful. And in the Math UC workbook, it actually has just a generic picture that shows you the A across from A, B across from B, and all of that to use for reference. But it's actually pretty easy just to fill this in and solve the proportions and to do it that way. Let's start off by actually thinking about, what are we even missing? We have angle A, angle C, so we're missing angle B. That's going to be something we have to find. And then we know side C, but we're going to have to find the sides for A and B. So that's the other thing we need. Other 2 things we need. Now, in these situations where we have angle, angle, side, or angle, side, angle, we're going to really easily be able to find the third angle, because if we know 2, we just need to subtract from 180, and that will give us our third angle. And there's more than one way to work this out, right? But essentially this is what we're doing, 180 minus 52 minus 17. So let's see, 180 minus 52 minus 17. 180 minus 52 is 128. 128 minus 17 is 111. B is 111. Now there's a couple different ways we could do this. We could go ahead and fill out the whole thing for law of sines. So we'd say sine A, so sine of 52 degrees over A, which we don't know, sine B, which we just figured out, over little b, and then sine 17 over C, which is 10. Okay, so you can set it up like this and then figure out what pieces to take to solve, or you could just set it up with 2 fractions at a time. Because what we're going to end up doing here is saying, I'm going to take the fraction where I know both parts, which is the one with C's, and I'm going to take one of the other 2 fractions and put those together so that I can cross multiply and solve. It doesn't matter what order we do it in, but in case you are OCD and have an issue doing anything other than alphabetical order, I'll find A first. So we're going to ignore the equation with b's right now, or the fraction that has b's in it right now. We're going to cross multiply here. Remember, cross multiplying is where you take the top of one fraction times it by the bottom of the other, top, bottom. So that gets rid of our fractions and lets us solve this. So that's going to be sine 52 times 10. So 10 sine 52. Now that is actually a number we can find. We'll use our calculator for that. But for now, so I don't end up rounding, I'm just going to write 10 sine 52. Then the other direction is a times sine 17. So that would be a sine 17. Again, this is a number. Sine 17 is a number. And so to solve for a, we need to divide by whatever sine 17 is on both sides. And so we're going to get our answer for a if we get on our calculator and do 10 sine 52 degrees divided by sine of 17 degrees. Make sure that your calculator is in degree mode. Mine's not. Now it is. And so if you're on your TI calculator, you can use the alpha button and then the y equals button to get a fraction if you want. You don't have to use it as a fraction, but you can. 10 sine 52 divided by sine of 17 is 26.95. So A is 26.95. If we did have a figure drawn out here, it might help us with the idea of like kind of checking to see if our numbers make sense. So based on the fact that C, it goes with 17, which is a really small angle in the broad scheme of things. And then B is our biggest angle, so that would imply that B should be a number quite a bit bigger than 10. Well, A is going to be somewhere in between those. So for now, at least, 26.95 seems like it makes sense. Now we're going to do the same thing, but with the B fraction. So sine 111 over B equals, and I'm still going to use this one that we used on the first one, the C equation. Technically, we could use sine 52 over 26.95, but two reasons not to do that is one, if we messed up on solving for A, then using that to find B will then make sure that that means we'll get B wrong as well. And also just sine 17 over 10, that's nicer numbers. So those are our two reasons. Okay, now we cross multiply. And divide by this sine 17. You should notice, pretty much like almost anything with math, there should end up being some repetition here, so that while the first few problems you do might feel like they take a while, at some point they should start feeling quicker. So, which is 31.93. So there we go. They gave us 3 pieces of information. We found 3 pieces of information. So that's all there is to it. All right, let's do another example. Example 2. So we have 2 angles again, B and C. We've got a side A. And this one I think is angle, side, angle. And I think that because the side we know, A, is not the same as one of the angles we know. So that's my guess without actually drawing out the picture to check. So we're only missing angle A. So we've got B and C, we're missing angle A. And then we know side A, that means we're missing side B and side C. So we know 3 things, we're gonna find the other 3 things. The angle that we're missing is the easy part because we already know 2 of them. We just need to subtract from 180. It's a shame that's 91 degrees instead of 90, or this would be a right triangle and we wouldn't have to do law of sines. We could just do good old, what we used to do with sine, cosine, and tangent. So katoa. 180 minus 65 minus 91 is 24. So I'll write down that answer here. That's 24 degrees. So I'm going to use the second way of writing law of sines this time, where the sides are on top, just so you'll hopefully get a chance to decide which one you like better. So side A would go over sine of angle A. And then we could do side B, which we don't know, over sine of 65. Now we actually can just do two fractions at a time. We don't have to write out the whole thing every time, because this is what we're gonna this is one of the things we're actually going to solve. So we'd cross multiply here and do 13 sine 65 equals B sine 24. So that means that to solve this, we need to do 13 times sine 65 and then divide it by what's next to B, which is sine 24. So we're going to do all that on our calculator, and it'll be a great time. 13 times sine 65. And then we're going to divide by sine of 24. Now, in case you're wondering if this is right because the 13 is in front, I'm pretty sure that that's fine. But if it makes us feel better to put it on top like that, then I'm certainly on board. So 13 sine 65 divided by sine 24 is 28.97 or 28.967, depending on what you want to round to. So 28.97. Okay, now we're going to find C. We're still going to use the fraction that had 13 and sine 24 because that's what we started off knowing both parts of. Although I guess we didn't start off knowing both parts. We had to find the 24, but we can be pretty confident that the 24 is right, so that's nice. But then we're looking for C, and that's going to go over sine 91 degrees. So we're going to cross multiply. That's 13 sine 91 equals C sine 24. We're going to divide both sides by sine of 24 degrees and then work this out. So these might be seeming kind of long, and it's definitely one of those things where as you kind of do more of them, it should start to feel faster. It should start to feel repetitive, which is good because that means you're getting the hang of it. So keep that in mind, that right now it might feel like you're spending days doing one problem. Oh wait, no, that's just me because I'm recording the second part of this on a different day. But it should start to feel faster. So assuming that I remembered the problem right, this is 31.96. Again, we could kind of look at the numbers we actually ended up with and decide if this seems reasonable. So side A is 13, angle A is 24, angle A is clearly the smallest angle. And so it makes sense that our other two sides ended up being bigger, right? Because that's how triangles work. The bigger sides are across from the bigger angles. So I feel pretty good about this. Let's look at another example. This example is one of those side-side angle cases. So Math UC, I think, kind of ignores the fact that it could be no triangle or two triangles and just gives us ones that are one triangle. So that's kind of nice. This does give us a triangle. There is going to be something a little bit different than that happens here, though, because we only know one angle. We're going to start it differently because we can't just start by subtracting from 180 to find the third angle. We need to go ahead and set up some of our law of sines. So we know A and A, so sine 104 over 34. And then we don't know anything about B right now. So if you're liking better where you go ahead and write the whole thing out first, that's fine. We can do that. If you're preferring to just write out kind of what we need at the beginning, that's fine too. You will be able to sometimes write less than maybe what I'm writing on each of these problems, but don't just write down the answer. Write down what you're putting in your calculator. That way if you mess up somewhere, your teacher has something to look at so they can figure out if it was a fluke that you got it wrong or if it's because you're not understanding part of how to do it or what. So we don't know anything about b, so we're going to ignore this middle fraction so that we can solve for angle c. So we're still going to cross multiply. And that means that we're going to do 29 sine 104 equals 34 sine c. I think I mentioned this earlier, by the way, that like I try to round as little as possible, that the more you round and the fewer decimal places you round to, the more you can kind of create a rounding error. So if you're wondering at times why I'm going to all this effort to put in 29 sine 104 divided by 34 altogether, then that's why. Now, what this gives us, I'm just going to throw out there, is not angle C, but is actually sine C. So it's going to give us a decimal. And then in our calculator, this is where we do the second sign button of our answer. And you actually can do that by doing second sign, second, and the negative button down at the bottom. We'll put in A and S for answer. So that it will tell us the angle. But if you just write down the decimal that you get from this fraction, then you haven't finished it. And since we had to find this first to get any of the other parts of this, then the other parts will be wrong as well. So make sure you remember that if you get something weird that's a decimal, you need to go a step further and get the angle. So let's see, 29 sine 104 divided by 34. I don't know why I did 105. 29 sine 104 over 34. See, it gives us this decimal, 0.8276, blah, blah, blah. But even better, we need to do inverse sine of this. So on your calculator, like I said, do second sign, second answer. If you're on Desmos, actually, I think I need to come down here and go to functions to grab inverse function, which is the sine -1. And that was really nice. It put the parentheses and everything like we needed it. So I couldn't just do like on a separate line second sign of my answer, so I put it around what I just did. So this looks like 55.85 degrees. So 55.85 is C. And I didn't actually write down what sine C was. It was, I don't have it anymore, 0.85 or something like that. So that's how we go about getting our our second angle, because we already know A is 104. Now we're going to take these two angles and subtract to get B. So 104 and 55.85, subtract those from 180. So 20.15. And then now you can either go back and go ahead and write this in to help you out, or just write a new set of fractions, right? Still think we should use the ones with A's, since that's what they gave us. But really, if we got something wrong along the way here, the nature of side-side angle here is that we do keep using something we already found. So it would be very easy for us to have accidentally messed something up, which is annoying. Well, it's one of the things I think I like about law of cosines better, is that you could, in theory, just keep using... Maybe I'm wrong. Never mind. We're going to cross multiply. This is going to feel like what we did on example 1 and example 2. So 34 sine 20.15 equals B sine 104 on the subject of rounding errors. If you are rounding differently, like you're writing down a number to 2 decimal places and then using that in the calculator, as long as your answer is within like 0.5 of what answer is in the solutions, or what answer I got, then that's probably just a rounding error. If it's something bigger than that, it probably means you actually typed in a wrong number somewhere, or actually did something wrong. So like if the answer was supposed to be 55.85, if you got anything between 55.3 and 56.3, like that's probably still fine. But even if you get like 57, That's far enough away that it doesn't suggest to me a rounding issue, but it could be that you just typed a number wrong. Instead of 104, you put 105 or something like that. So it could be a good idea to go back and look for where you might have messed up. Let's see, 34 sine 20.15. Divided by sine of 104. Yes. So that's 12.07 for B. So box our answers. 1, 2, 3. Oh, this needs a degree symbol. There we go. That was an example of side-side angles. So just remember that if you end up with sine of something, you're not done. You have to use second sine to finish it to get the angle. Finally, now this isn't anything new. It actually is very similar to, I think, example 2. What I would love is for you to pause the video and see how far you can get with this on your own. Because sometimes we can be, listening in class or listening to a video and be like, I've totally got this, and then we start to do the problem on our own. It's like, I don't know what I'm doing. So this gives you, my hope is to give you a chance to be walked through this. So you have to start off by trying it. Then if you get stuck, start the video to see if I explain how to get unstuck. Hopefully I will. So pause now. Welcome back. That was so quick. You did such a great job. Let's do this. So we know A and C. Let's find angle B. So that's going to be 180 minus 20 minus 126. So do I want to do this in my head? That's the same as 180 minus 146, 434. Okay, so B is 34. I should have just done it on the calculator so I'd feel more confident about it. Okay, it doesn't matter to me which way you do law of sines, if you put the angles on top or the sides on top. Just pick which way you want to do it and stick with that. So since I've done 2 with angles on tops, I'm going to do angle on bottom on this one. So we don't know A, side A, but we know sine of 20. We now know all of B, so 18 over sine of 34. So that's a fraction we're going to use. And then we don't know C, sine 126. For this, it's actually really easy to kind of like use all 3 fractions and just ignore the fraction on either side as we need to. So here this would be A sine 34, cross multiplying 18 sine 20. This is a good place to pause if you were stuck earlier and want to see if you can type this into the calculator correctly. So 18 sine 20 divided by sine 34. So the only difference between what I'm doing and how it looks and what it should look like on your TI calculator, if that's what you're using, is that you actually can make it look exactly like this by using alpha y equals to create a fraction. But you also can close your parentheses after 20 and use just a normal division sign and then type sine 34. You might take a moment to play around with this if you haven't already to make sure that you can get this answer of 11.01 because you need to be able to replicate that basically, right? You need to know how to put it in the calculator yourself. You also, of course, could download Desmos, although if you're out of school, they probably don't want you to use Desmos on tests, so just keep that in mind. So this was 11.01. And now we will do these two. Cross multiply. So 18 sine 126 equals C sine 34. So divide by sine of 34. And gotta type that in. 18 sine 126. That's the second time that I've like randomly put a number slightly incorrectly, so There we go. 26.04. There we go. How'd you do? Hopefully it went okay for you. If not, hopefully you learned something from that one. And definitely, if you need more help with this, feel free to leave a comment asking a question, or, you know, leave a comment asking for more help or something. But hopefully this went well for you. Thanks so much for watching. I enjoy making these videos for you, and I'm glad of anybody that I help out. So great that I can use the internet to help people, both that I know and that I don't know. So please give this video a like if you liked it, or if you like me, and give it a thumbs down if you're a terrible person. No, I'm just kidding. Like, I don't want to put that out there. So thanks for watching. Like, subscribe, all that.